Alright, let's start off with number 10 here, and it says to find the C that satisfies the mean value theorem for f of x equals x over x plus 1. So, and they gave us over the interval -4 to 2. So f of 2 is 2 over 2 plus 1, which is 2/3. And f of -4 is -4 over -4 plus 1, which is 4/3. And so to find that slope, we take 2/3 and subtract 4/3 and divide that by 2 minus -4. And this becomes -2/3 divided by 6, or -2/3 times 1/6. And that becomes -1/9. Okay. So, now what we need to do is take the derivative, and that's going to be ho d high minus high d ho all over ho ho. And when I simplify that, I get 1 over x plus 1 squared. Now, let's see, where did I make the mistake? Oh, let's hold on just a second. Alright, I found the problem. It should be to -2, which would make this -2 or -2, which makes this thing +2, which makes this thing +2, and makes us get rid of all of this stuff. And 2 minus 4/3 is 2/3, and that would make that -2. Over 2, which makes this whole thing 1/3, which makes life much better, because now 1 over x plus 1 squared equals 1 over 3, or x plus 1 squared equals 3. I can take the square root of each side, and x plus 1 equals plus or minus the square root of 3. So x is equal to -1 plus or minus the square root of 3, but the one we're looking for is x equals -1 minus the square root of 3, because the square root of 3 is going to be bigger than 1. And remember, we need this to be in the interval -4 to -2. So that is the one we are looking for. Well, okay. On to number 11. The height of an object t seconds after it has dropped from a height of 500 feet is s of t equals -16t squared plus 500. It says find the average velocity of the object in the first 3 seconds, and then use the mean value theorem to find when the average velocity equaled the instantaneous velocity. Well, the first 3 seconds, the interval 0 to 3. So let's find s of 0, which is 500, and s of 3 is going to equal -16 times 3 squared plus 500. And that is going to be -356. So the average velocity, we can call that V bar if we want, is 356 minus 500 divided by 3. And with that I get -48. So now they gave us that position function of being -16t squared plus 500. Remember, velocity is the derivative of that, so it becomes -32t. And we want to know when that equals -48. So t is equal to -48 over -32, and that's 1.5. And the units on that is seconds. Alright. Number 12. Ooh, look at number 12. Use a trig identity to show that f prime of x equals 6 over pi minus 4 times the sine of 2x. That's what we want to end up with. F of x is equal to 6x over pi minus 4 sine squared x. So let's take the derivative. 6x over pi is 6 over pi. Minus, okay, 4 times 2 is 8. We leave the sine alone, so we get the sine of x. And then we're going to take the derivative of the sine and get cosine of x. 6 over pi. Well, let's see. If they tell us to use that identity that the sine of 2x is equal to 2 times the sine x times the cosine of x. Well, if I look at that thing, that's kind of 4 times that, so I get minus 4 times the sine of 2x. And there we go. And that's done. Now, let's see. Part B for this thing said that if Rolle's theorem applies, find C that satisfies the theorem in the interval and round your solution to 3 decimal places. So if Rolle's theorem applies, Rolle's theorem does indeed apply here. So this becomes a matter of taking 6 over pi minus 4 times the sine of 2x and setting that equal to 0, or 6 over pi equals 4 times the sine of 2x. Oh my gosh, if we divide by 4 we get 3 over 2 pi equals the sine of 2x. And this would be a great time to get out your trusty graphing calculator and look for where those two things intersect. And remember, we're looking at the interval from 0 to pi over 6. So a good thing to do would probably be to set your x window from 0 to maybe 0.6 and see where they intersect. And when I did that, I got x equals 0.249. Alright. 13 says to find the C guaranteed by the mean value theorem for f of x equals 2 times the secant squared of x, and they want this on the interval from negative pi over 4 to pi over 4. Okay. f of pi over 4 is going to be 2 times the secant squared of pi over 4. And f of negative pi over 4 is equal to 2 times the secant squared of negative pi over 4. Now the thing to remember is that the secant is an even function, so the sine of x is equal to the secant of x is equal to the secant of negative x. So these two things are equal. So basically what they're saying is the slope of the secant line is 0. Right? So we've got the secant line of the secant graph. Fun. So now what we can do is take the derivative of that bad boy. And we get f prime of x is equal to 2 times 2 is 4. We leave the secant of x alone. Derivative of secant is secant x times the tangent of x. Okay, set that equal to 0. Now, you could graph this here, or if you're really good and you remember your trig identities, you realize that this thing is 4 times the sine of x over the cosine cubed of x, and that thing is supposed to equal 0. And the only way that thing is equaling 0 on that interval is if x equals 0, because the sine of 0 is 0. Okay. Otherwise, you could graph it and hopefully you get the same thing. Number 14, they want us to approximate the lower sum of f of x equals the square root of 4x minus 1 on the interval 2 to 4 with n equals 4 intervals. Okay. So the thing to do would be to set this up in a table, and you're going to find that you want x equals 2, 2.5, 3, and 3.5. Find the corresponding y values, and that's 2.646, 3, 3.317, and 3.606. So then to estimate that area using a lower sum, what we would want to do is multiply the interval width times the height, and the y value gives the height. So the area, quite honestly, is going to be 1/2 times the sum of all those things. 2.646 plus 3 plus 3.317 plus 3.606. Add all those things up, multiply by 1/2 because that's the interval for each of them, and I got 6.285. Okay. Number 15. Right. Use the graph to evaluate that integral. I broke that thing into 1, 2, 3 trapezoids, and I found their areas and added them together, and I got 27. Alright. Number 16. Oh, I tell you what, we're going to end this video right here, and we'll start off with number 16 on the next one.